I'm Ioannis from the University of Cambridge, and today I'm very happy to be here to give my presentation about the knowledge-driven role-based building geometric digital twin construction state-of-art review. Today that we have 4 presentations are good, and I'll talk about the information delivery, the data delivery during the like building management process, but there are many building assets in our world that they don't have the digital format of the building. So this comes to our solution that scan to the digital twin process. The very common method is to do the first step is the data collection. We use LiDAR or RGB camera or thermal camera to do the data collection, and then to establish point cloud data. And then we process the point cloud data to identify it, for example, the object detection, classification, and to do the semantic segmentation. And then we establish the digital twin model from the data-driven or model-driven or hybrid-driven method. And then we got the digital twin. However, how we use the digital twin, come from the point cloud data. So this comes to my why I start this research. So let's say the current situation that we got many data, many digital twin. We say that it comes from the scanning point cloud, no matter what the data source of it. But we want to use this model in our management process, right? So in management progress, we have the definition of asset information model or asset information management during the management process. And what is the difference between these two? I think first, we need a higher level of detail. Currently, we have level of detail from 200 or 300, the maximum model, and it kind of like most of the research that link the spatial relationships in the model and link the semantic information of the model. So I start from the end of the story and think what we can do now. So this comes to my research question that how to effectively build the spatial relationship and as much as semantic information during the scan to digital twin process. So this is our common process that we deal with the point cloud data, and we do the semantic segmentation to categorize into the different building elements. For example, the space, windows, walls, doors, slabs, columns, etc. And then we want to do the digital twin that with the spatial information like in the model. So I'm thinking that because each element of the building actually has their own story, that they have its own characteristic. So each building are different, but they have the the unified characteristics, I think, for the different elements. For example, the column, the door, the space. So I want to find the knowledge of the building that and to explore it, how it can be processed from the point cloud model to the point cloud data to the digital twin. So, but at this stage, when people do the point cloud processing, actually we have the rule-based or knowledge-based processing method that they already, actually many researchers already use the knowledge principle of the building to segment it. So I'm thinking that if I can keep this knowledge and extend its value during this generation process, so it's kind of like lead to my research objectives. So in this conference paper, I want to review the rules and knowledges that already used or common used in the digital twin construction phase, and explore how this rules or knowledge can be used in the further constructed digital twin development, for example, the enrichment or the knowledge fusion with the other domains. So here's my methodology. So I scanned the recent research, the recent 10 years research, and with the keyword, for example, the digital twin generation and scan to beam. There are many papers on this. So I focus on the rule-based and knowledge-based construction method, and I categorize these rules into 3 categories. And also I focus on the indoor building environment. So the first one is the shape rules. This rules is kind of focused on the geometric building information or geometric characteristics of the indoor elements or the space, and also the typological rules. And this rules is kind of focused on the relationship of different elements or different categories elements, the relationship information of our elements, and also focus on the components and also the space. But for the semantic rules, it's kind of like based on the previous exploration of the shape rules and typological rules, and then people do the further step exploration and to the further step inference of the current that what we see from the point cloud data. And this is like kind of how to say, like to inference the potential knowledge, or we can, according to the knowledge of the building, to see that what is behind the scanner. So here I can't do the whole like presentation of all the research result, but I raise up some key research of here. The first one is the building elements of the shape-driven rules, and they focus on, most of them focus on the walls. And also to understand the indoor environmental scene of this whole to understanding that to develop the point cloud into the different planners and to do the segmentation. And also the interior space to explore the connection of the different subspace and then connect to form to a whole room. And then the typology-driven rules is more interesting because many people focus on this part. For example, the connection of the walls. So they predict the connection of the wall to perfect to make the connection in the digital twin to make it perfect, especially the joint part of it. And this research is talking about if different surface of the wall, they are in the same space or they are in the same wall. So use this method to segment the indoor space. And also this is the research about the identification of the wall and the door, but even it has offset between them, but we can still confirm that the door is contained in the wall. So here is the connection, to explore the connection space between the stories. So the staircase can be explored and divided into different space and different planar, different slab to define that this space is a connection space. And then it comes to the semantic-driven rules. There are also many research about this, and this diagram is about to divide the different space of our plan, and then we can see that different color, they actually have different function. So the orange color space highlighted is kind of like a work as a corridor of the building. So this information can be extracted directly from the point cloud actually. So here I actually conclude some rules that I find in the current research that I don't have time to read it one by one, but maybe the first few one is maybe each room should have at least one door, and this at least one road connecting each room and every stories, something like this. So this knowledge, this inference rules is actually established based on the shape and typological rules, but it can do the further step. So this is the proposed initial knowledge graph framework, but I didn't do much developed in this paper right now. But we can see that the class property, the relationship of the building is actually can be extracted from the shape rules and also the typological rules. And the semantic rules can be the inference rules, reasoning rules in the knowledge graph. And here's come to my discussion. During the process that I search all of this research, I find that data-driven method and model-driven method, actually they are combined together. And all the rules I mentioned, they don't use the individual kind of rules. They also to combine them together. So this is very important that we do the further step exploration. And then the building knowledge is essential for the digital twin reconstruction. And the knowledge and the rules that we used should be explored from the point cloud data processing, and it can also be extended or reuse it to the digital twin construction. And if we do the scan to graph kind of method, and this establishment is important for the digital twin enrichment and the other domain knowledge fusion. So this is the whole structure of it, and currently I'm in this paper. I only do this the part 2 of it, which is review the current rules that used in method in the current method. And in the future, I will to explore the unified method to generate the knowledge graph of the building from the point cloud data and integrate the typological and semantic information to the digital twin. Yeah, that's my presentation. Thank you.